Right, we're recording. Just so you guys know. Okay, starting now. Good day, gentlemen. Thanks for taking the time to do this training session. We're doing a training session on MEM 12023 performing engineering measurements. This is very much the start off, the kick-off of the whole unit of competency. It's obviously a very broad sphere that we're covering in terms of measurements. So today what we plan to do is get through types of measuring systems, units of measurement. We'll then, next session, what we'll do is select correct length measuring tools, which today's focus is on length measurement. Yeah. Obviously with length, volume, mass, temperature, which is all used in the engineering sphere. Right now we're doing length measurement and Alex will be having fun with that. Right, so kick off. Missed by how much? What is the normal saying? A hair's breadth. What's a hair's breadth? How much is a hair's breadth? 1 mil. 1 mil?
Very stiff.
Oh, I don't want to say that, but yeah, I get what you're saying.
What's an inch?
An inch? Oh. Can we measure it?
Yes.
Sure.
Can hair be measured?
The thickness of a hair? Yeah, we can. Apparently you've got to get a very specific laser, refract the light from the laser at a certain set distance. So you've got your hair there. Not today. That's not, we're not going there. Alright, we're not going there. Alright, so I'm not going to tell you what a hair's breadth is. We'll leave that to the end. Alright, measuring systems. We've been measuring stuff since Noah was building arks, and so ever since we've had written record, we've been measuring things, whether it be length, weight, distance. But are they all the same? You go to a pub and you say, I'll have a pint. How come one pint is bigger than the other pint? I'm sure you guys have all ordered a pint before. Why are they different? One's an imperial pint, one's a metric pint. One's actually a metric pint, even though it equates to 15, that's 15, sorry, it's actually 20 fluid ounces. That's 20 fluid ounces. That's 425 milliliters, which is 15, give or take decimal places. It's about 15 fluid ounces. That's 20 fluid ounces, that's what a pint used to be. But now everything's built on the metric system, and 425 is the perfect size glass.
So they took beer away from us.
You're being robbed. Okay, like, I'm just going to say that in a nutshell. Okay, so you've got the metric and the imperial system. What's the difference between the two? What's the main difference between the two? What did you say? You said inch?
Yeah, so the main difference really would be is imperial is fractions.
Bang on the money, alright? So, the metric system uses inches, feet, yards, miles. The metric system uses meters, grams, liters. Liters is your, whatever, meters, grams and liters. That's their base units. What is the base unit of the metric system? Is an inch, I think. Right, or a yard. And the big thing is fractions. Metric system, or otherwise known as the ISO system, is a universal system. The world is pretty much going there, and I think Australia is very much on that stream already. I think all the new education gets done in the metric system.
Yeah, for sure. Yeah.
What-
Good to still know Imperial, I think.
Absolutely.
Yeah.
So the what sets the metric system apart from the imperial system is your conversion of units is all multiples of 10. Whereas your imperial system, like I said, is all fractions. Right?
Yeah.
I don't know about you, I don't know fractions. Quarter of an inch, 1/32 of a what? And an inch is that. Fair enough, a meter is that, or thereabouts. But I can take a meter and divide it and just keep dividing it in 10. Every time I break it up into tens,
And you don't have to use fractions.
I'm getting smaller and smaller and smaller, and I can go to that far down that we're talking about nanometers, which is 1/1,000,000th of a meter. Right. So, any questions on that? That's measuring systems at the moment. What we're going to do, we're going to quickly breeze through conversions. Do it when the computer wants to do it. Right, so I keep moving the mouse around, that's my fault. So there we go. What's our base unit of measurement for the metric system length measurement? I said it earlier. Meter? 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 Do you know what a millimeter is?
Yeah.
A millimeter? It's all in the name. Our base unit for
1/1,000,000th of a meter.
our base unit for length measurement is a meter, even though it is a big thing. So you've got a kilometer. Why is it a kilometer? And this is, I have printed out, and I will give it to you once we finish our training. I've printed this out without the explanations. It's a little cheat card. You can put in your pocket. You can use it with your assessments. You can use it when you're at work. It's a good reference resource that you can keep referring to if you're not sure. Where am I? What am I measuring if I'm measuring 3 micrometers? Because
You can see it down to the decimal there.
it tells you where you're at in terms of decimals, and it tells you which way you're going. Okay, so to make it easy, when you're going from a unit of measurement to go from kilo to meters, so kilometers, you're going down the chart,
Yeah.
you divide by 10. So wherever you're going, I've got 3,000 kilometers. How many meters is it? I divide by 10, 100, 1,000. Each one is decimals of 10, or multiple of 10. Right? I've put a box around here. Take note, you're going from
Yeah.
3 decimal points to 6.
Yeah. So that. Yeah. Okay. Yeah.
There we're going by 1,000
little
each.
card.
A little helpful.
Yeah.
Perfect little guide. Like I said, I've got them printed out, laminated, so you want it, and it will fit in your little notebook, in your little pocket. I'm going to give it to you guys. That's an awesome resource. I'm actually going to, later on when we do the next session, I think it's the next session. Oh, no, it's the next page. Right. So, any questions there?
No.
These are the ones that we hear the most.
Yeah.
All right. In the engineering sphere, where we're dealing with precision manufacturing, precision fits, and components that start from little micro machines to massive machines, a lot of your clearances are really tight, they're really small. So a lot of the measurements, and even in the building trade, use millimeters as a standard. It's not the base unit of the metric system. It's just, it is the most versatile in that you're measuring in increments of next to nothing. Right, so moving on. This is a summary page of what we've pretty much done. This here is a nice little poster. I've printed out a poster for each of you. I'll be handing it out once we complete it. This is nice to stick above a desk or in your cupboard. It's the same thing in different ways. This is what you're doing to go from like millimeters, what is it, centimeter to meter, millimeters. It just gives you a quick reference guide. These are your most often the types of conversions that you're going to do is going from centimeters to millimeters. They're also just giving you the replacement of that, going smaller, going bigger. Oh, yeah. What I like about this is it gives you more than just length. It also tells you it's a reference guide for later on when you use grams, or so mass and volume. Temperature, that's a whole different ballgame. Temperature is pretty much Celsius. Right, so any questions from here? That concludes the first part of our training for length measurement. After this, we'll be going on to tools we use, correct tools used for length measurement, and then later on down the road we'll be doing volume and mass, and then the assessments. Is there any part of this that you guys didn't understand, maybe?
No.
Comfortable?
Yeah, it's pretty good.
You enjoy the setting?
Yeah.
Yeah. Alright. Cool. Thank you very much.
Cheers, mate.
Right. Tool for the job. Quick and easy. It's about a meter and a half. How accurate is that?
We're all done.
Eh?
We're all done.
Alright, I don't know how accurate it is. So, we've got a few tools here. We've got a long, it's a construction tape measure, which you're going to measure centimeters to, what's hectometers? 100 meters? Right?
So after we're going increments of 100.
We never call it hectometers. We always speak of meters, 100 meters, 200 meters. Then we jump to kilometers. 500 meters is half a K. Yeah. Okay. I'll just put that in to be funny.
About 40 bricks.
The next one, tape measure, we're going to measure from millimeters to meters. It's not going to be any accurate lower than that. What's the next one? Laser pointer. You know, I wouldn't trust that thing, a laser measurement more than meters, but you can measure up to 3 kilometers in some of them. And then micrometers to millimeters. So now we're starting to get to these thousandth of a millimeter, a thousandth of a meter. And that just to measure your waist.
I need a big one.
I'm starting to have to look for a bigger one as well there. Right, so that's the names for them as well. The most common ones you're going to find in the engineering sphere is steel rules, whether they're attached to squares. Steel rules. What's the smallest measurement we see on those steel rules? Millimeters?
Yeah.
Vernier calipers? They're not verniers, they're vernier calipers, to be precise. Tape measures. And micrometers. Right, so starting with the largest measurement of the lot.
That's
Don't go there.
okay.
So micrometers. We're going to play around with these a little bit. So how do we read the tape measure? We've got two scales. Now I've put that in there because
Imperial fractions.
a lot of the old machines still work in fractions, work in imperial measurement. A lot of tape measures do still have the metric system, the imperial system on it. I'm not going to look at that. So what do we have? We have a tape measure. At the bottom you've got a scale, you've got small little lines, the bottom lines, those are a millimeter each. Then they're nice, they give you a half a centimeter indication, and then those are centimeters. How many millimeters in a centimeter? You need your cheat sheet, huh?
Yeah.
Right, so that's 10 millimeters
10.
to a centimeter. How many centimeters in a meter? 100. Okay. So 1 meter is 100 centimeters or 1,000 millimeters. Most of them are indicated with a 100 or a 1M. Right. How is the steel rule any different? It isn't. Steel rule, this one's got half millimeters on it as well. Yeah. it's a Boilermakers
Yeah.
rule. As you can see, it's been welded, it's been ground, it's been painted. Anyway, so the small one is millimeters, centimeters, decimeters, 600 mil. I didn't bring my meter long rule. Alright, so tape measures and rules are very much the same in their accuracy. What's the smallest you're going to measure in a millimeter? The tape measure and the rule. Alright, if you're lucky, half a mil. If you're measuring half mils on this tape measure, you've picked up the wrong tool. Because your next one is these bad boys here.
My favorite.
They can be pretty intimidating because you've got 3 scales. This one's also got the inch. This one's got the metric scale that runs on the top, ignoring the imperial scale on the top, ignoring the imperial scale. You've got what's called the main scale at the bottom, which is each small division is same as a tape measure, a millimeter. Every 10 millimeters is a centimeter. However, you've now got a third scale, which is your vernier scale, which then breaks it down into tenths of a millimeter. Right. How do we read it? Where the zero, there's a zero on the vernier scale. Grab one. He's a Boilermaker. He hasn't seen one of these yet.
Oh yeah.
A lot, yeah. Well, this uses an hammer.
I thought it was to pick his ears, to clean his ears.
Nah, this one.
He knows what this is.
Alright,
Stone. Don't you throw that at people?
When you do.
that is bosses normally. Alright, so on your vernier scale, there's a 0. So your first measurement you got to do is millimeters. Wherever the 0 has passed is the number of millimeters. So you see on this example, the 0 has gone past the 11th millimeter. It has not gone past the 12th millimeter yet. So you know you're on 11 millimeters. You haven't quite got to 12, so it's 11 point something. Then you look at where your vernier scale, you see those lines don't, that line does not line up with anything, that doesn't line up, that almost lines up. You see how that lines up with another one? That gives you your decimal reading. Alright? Make sense?
Yeah.
Yeah.
Cool. Alright, we're gonna have some fun now. We're gonna play around a little bit.
Maybe one of these for that,
Yeah,
though. Actually, this is the smallest one, yeah.
Select the measuring tool to measure the width of that gate and tell me what is the smallest size door that's going to fit in.
Well, I'd say take measure.
Alright, measure it. Select the right tool to tell me how long that is, and I want to know to the first decimal place what the width of that is in millimeters.
Take measure.
The width. Take measure? Yep.
Am I taking
This way,
into account these spare pieces? Or just the main?
Just the gate. Just the gate. What did you get?
440 centimeters.
440. Perfect, on the dot. Good, on that. To the 10th of a millimeter wide.
I beg pardon?
What's the width of it?
Yep.
To the 10th of a millimeter.
38.20.
38.20. I'll take that.
It said 2.7.
So again?
It was 2.7.
2.7.
Mm-hmm.
Why did you say 2.7?
Or what I said. So it was at 2 feet. 7.
Oh, 2 feet.
Now you don't use, if you're working with a metric system, the imperial system you ignore completely.
Okay.
So, where you measure across there, like you did it perfectly right, you're only looking at the bottom scale.
Yeah, okay.
So that's 70
Yeah.
centimeters.
Millimeters?
70 centimeters.
Yeah, so it's centimeters,
So that's 2 millimeters multiplied by 10. 700 mil. Yeah?
Yeah.
Alright, so you were looking at that, adding that to that.
Yeah.
You only, so it gets a bit confusing. You wouldn't normally pick up one of these for yourself. What you would do is pick up one with that. Alright, that's, you'll probably find these guys have all got these in their toolboxes as well. A lot of the engineering, you'll pick up a drawing that will go 2 inches and 7/8. And then you go like, oh,
Black book.
what is that? Yeah, black book. Or you go 2, I don't know, 7/8, it's about 65 mil. 65 mil. It's just an easier reference. Alright, so you guys happy with that?
Yeah.
Yeah. Alright, let's move on now, because the vernier in your context in a gym, are you ever going to pick up a vernier to go, oh, this piece of equipment needs to,
Yeah,
I'm
no.
setting out my gym, I need to do
The most I need is a tape measure.
tape measures where you're going to
Yeah.
So, it's nice to know if you needed it. In their context, this should be second nature. And then especially when you start getting into the fitting side of things, boilermakers do everything. But when you start getting to the fitting side of things, when you're fitting a bearing, you're not allowed to have more than 0.05 of a millimeter clearance on some of them. Some of them have got to be, you've got to have, the casing needs to be 0.05 of a millimeter smaller. Are you going to do that with a vernier, or a tape measure, or a rule? No. Either way, you could have used a rule. On your first one.
Can't read it. Oh, that's flexible.
That's the only reason I let you go now. Alright, so verniers. The vernier caliper. It's also called a vernier caliper. Vernier micrometer. Interesting concept. There's an interesting idea. Why do we call it a micrometer?
Because it's a micrometer.
It's a micrometer. That's how lazy we are. We just call the tool the unit of measurement. It's a micrometer.
You know what it is, eh?
Alright, so
I'm not trying more force for asking.
you should be able to.
Can be a bit tricky these ones, eh?
In part 3 of our 4-part series, we'll show you how to read a metric micrometer. If you're not familiar with micrometer terminology, please view video 1. The pitch of the screw thread is 0.5 or 1/2 millimeter, so a full revolution of the thimble moves the spindle 0.50 millimeters. The reading line on the sleeve is graduated in millimeters above the line. Each millimeter is divided in half below the line. The beveled edge of the thimble has 50 graduations, each representing 0.01 millimeters. Every fifth line is numbered. The number of millimeters plus half millimeters visible on the sleeve, plus the hundredths of a millimeter on the thimble, is your measurement. In this example, the last sleeve line visible is the bottom line after the 5, for a value of 5.5. The thimble scale value at the sleeve line is 28, so the measurement is 5.5 plus 0.28, or 5.78 millimeters. Many metric micrometers have horizontal lines above the sleeve scale positioned to work with the lines on the thimble as a vernier scale. Two types are available. The first has 6 vernier lines and provides a measurement to the closest 0.02 of a millimeter. The second has 11 vernier lines and...
So, again, look at what he referred to this as, the vernier scale. It's a static scale, works exactly the same way as a vernier does. He speaks very quickly on this one, so we'll go
and
over
measured to the closest 1,000th of a millimeter. Even if the metric micrometer has a vernier scale, if a part has a larger tolerance, read only to the closest hundredth of a millimeter. Since each metric micrometer has a 25 millimeter range, the sleeve scale for larger capacity tools will begin with 25, 50, or 75, as well as 0. For instance, the scale of a 225 to 250 millimeter micrometer would begin with 25. A 150 to 175 millimeter tool with 50, and a 175 to 200 millimeter tool with 75. The lower number of the tool's range, plus the thimble and sleeve reading, is your measurement. With a little practice holding the micrometer in part, turning the spindle with just the right amount of force, and interpreting the information on the thimble and sleeve, you'll be able to make an accurate, reliable measurement every time.
every time. Alright, I do not have any commercial agreement. That was just a very good instructional video. He spoke very quickly, but essentially what it comes down to is, and you're welcome to grab a vernier. What it comes down to is on the vernier, you've got major scales, micrometer. You've got your index line, you've got millimeters at the top, so each division on the top is a millimeter. The numbers indicate number of millimeters. The division at the bottom is half millimeter. So as you're screwing it open, as you're unscrewing it, it will go past the first top line. You'll then go halfway. You get the bottom line, which is a half a millimeter. If you turn the micrometer, so if you get your,
So if you go over that half line,
so you get it on the 0 on the little spindle, right? Now you turn it towards you, if you will. You turn the top towards you.
yep, so that'll be your
You'll see the divisions on the spindle
5,
will go 10, 20, 30, 40, 50,
5, 6,
and then the 50 is your next millimeter line. correct? So whatever you read in between the millimeter line or after the half millimeter line, whatever you read on that, you add to 0.5. So if it's 0.13 on there, you add that to 0.5.
0.63.
So it's 0.63, and then whatever the millimeter number is that you've gone through. So there you're reading to the 100th of a millimeter, right? Because it's the second decimal place. Only when you get that scale that sits at the top of the shanker do you start getting into the micrometers. I don't have an opportunity, or I don't have a need for them, for a proper micrometer, because I don't ever go past 100th of a millimeter in my workshop. When you start looking at precision engineering, you will be able to measure down to the third decimal place, which is the micrometer, 1,000th of a meter. Are we sort of there?
Yeah.
You got that? Awesome. All right. When we started all of this, hair's breadth. 0.08 of a millimeter.
Is that it?
That's it.
It's probably small. Yours are.
Yeah.
Yours are M16s.
So, with that in mind, do we have a tool there that could measure that?
Yes.
That could measure it?
Yeah.
Because you're on 100th of a millimeter. Not this one, this is a 75 to 100 mil. But a 0 to 50, a 0 to 25 micrometer, you could actually measure the depth of a hair.
Did you
You got digits too. That's, this is, yeah, big money. But a lot of equipment goes into the digitals. You get inside marks that are going digital now as well.
Really?
Which is like,
how accurate are they, the digitals? Are they more accurate than mechanical?
they are equivalent
Yeah.
to whatever decimal point they are calibrated to. The thing is that they've got to be calibrated.
Calibrate, and I guess it can take out human error than
Yes.
has the digitals, yeah.
Yeah, it takes out a bit of human error, but
Yeah.
with anything, and this is again our hair, when you use a micrometer, you have to put a little bit of force onto it
Rock
to
it backwards and forwards, find that sweet spot.
to get it to make contact. Now a hair is not going to allow you to do that because it's just going to collapse. It's practically see-through. What's the right pressure? That's the right pressure. Okay, so when you make a measurement, every single one of them has got a little ratchet that says to you that is where you are calibrated to. Again, what's the difference between that and that?
Nothing.
So there's a big difference.
Is it?
You'll probably get 2,000th of a millimeter difference in your reading.
If you spin it.
Because steel bends, even steel bends. That micrometer, these little plastic pads on there are for you to hold it, so that the heat from your fingers does not expand the metal. You're measuring 1,000th of a millimeter.
Oh, like this.
It starts getting well. In most situations, when you're holding a mark, you're holding two components. So you're sitting there, you're holding this,
Like that, yeah.
and you're measuring like that, or you're measuring like this because you're out in the bush. You can't put this in a vise every time and go, okay, I'll measure this perfectly. But when you're talking 1,000th of a millimeter, unless you're building rockets to go to space, I think you'll be alright. Alright, so to conclude, what's the current system of measurement that we use today? Metric system, correct. How do we convert the units?
With your G cards.
Times 10. Or divide by 10. Okay. Can we name the tools that are used for length measurement?
Yes.
What have we got?
Vernier calipers.
Vernier calipers, micrometers, tape measures. I think we're on there, mate. Alright. So, moving on. What's next?
Measurement of volumes and mass assessments.
So, and then assessments. Right. The assessments, guys, it's going to be a very similar sort of environment because of the complexity of measurement. We can't say to you, you can only, there are certain techniques and principles. As long as you measure within that, you're going to be alright. Okay? You got your little cheat sheet. So when you go, oh, what am I doing? That's millimeters plus another, okay? Guys happy with that?
Yeah.
Thanks, mate.
Any questions?
No.
No, I'm good.
Yeah, 3 o'clock.
Yes.
Thanks, mate.